Hey everyone, welcome back. In this video, I'm going to show you how to plot indicators using real-time data. I made a video a few years ago on how to do the same, but I only used static historical data. But in this video, we're going to do the same using real-time data. And before we get started, I just want to mention that I'm not going to use the standard lightweight charting library offered by Tradingview. I'm going to use a slightly modified version that supports multiple panes. The same library that I used in that video. So just keep that in mind and let's get started. I'm going to create two folders. The first one is client, where we'll write the client side code, and another one is proxy, where we'll write the server side code. Again, we're dealing with real-time data and we need to make API calls to the exchange. So we cannot do them directly from the browser. We need to use a proxy server to achieve this. I talked about this in the older videos, so I'm not going to repeat those again. First, we're going to create a simple static candlestick chart, and then we'll increase the complexity as we go further. First, inside the proxy server, let's first initialize the project and install all the dependencies. To initialize the project, I'm going to run the command npm init:\y, and then we're going to install these dependencies. Quickly explained is required to avoid CRS issue in the browser. Again, I talked about these extensively in my older videos, so I'm not going to repeat myself here again. And Express is to create a simple Express server to be able to create routes. GOT is to make API calls. Socket.io is to facilitate real-time connection between the server and the client. And WebSocket, WS package, is to establish a WebSocket connection to Binance Exchange. And finally, W indicators is to calculate indicators. Let's hit enter and install the dependencies. Alright, all the dependencies are installed. Finally, I want to install NodeMon as a dev dependency so that whenever I modify the code, the project is automatically started. Alright, NodeMon is installed. I'm going to create a script called start. I'm going to create a file called proxy.js shortly, and then whenever I modify the code, the project is automatically restarted. Alright, now let's create a file called proxy.js, and this is going to be the main entry file, and let's start the project with the command npm sudo npm start. Alright, now let's start writing the server-side code. First, I'm going to create a simple Express server on port 4000. And I'm also going to use the CORS middleware to avoid CRS issues in the browser. Then I'm going to create a file called klines.js, and inside this klines.js we're going to create a class where we'll store all the candlesticks, both the historical and the real-time candlesticks. So first, let's import the module GOT to make API calls and create a class called Binance Kline WebSocket. And inside the constructor, I'm going to default the symbol to BTC USDT and interval to 1 hour. Again, we can make it more flexible and be able to change these dynamically, but to keep it simple and short, I'm going to default these values. And then inside the constructor, we're going to set the initial values. And to store klines, I'm going to use a map instead of object or array. Again, map works very similar to objects, but map is more streamlined in terms of how you add data or retrieve a particular value. And you can also have non-string keys. So it's overall more polished and offer similar performance compared to objects. So we're going to use a map to store candlesticks. And then we're going to create a method called initialize. So inside this initialize method, it's going to be an async method. All we do is we retrieve the last 1000 bars and then set the value to the klines, this.klines variable. So we're going to make API call using the GOT module and then retrieve the last 1000 bars. And we're going to iterate through each bar and then set the values in the format that the Tradingview charting library accepts. So your timestamp is going to be in the seconds, and we have open, high, low, close, and volume. And then we're going to set the values to klines.set. And then we're going to create a method called getKlines where we can retrieve the klines whenever we need them. Alright, let's save it. And let's go back to the proxy.js file. Here we're going to first import the class that we just created, and then we're going to create a socket.io server. Again, we need to use the CORS options to avoid any CRS issue in the browser. And then we're going to initialize an instance of klines class, and we're already calling initialize method inside the constructor. So this will, whenever you instantiate the object, it will automatically retrieve all the historical bars. Alright, and then whenever a new socket.io connection is received, I'm going to emit all the historical klines on the kline topic using getKlines method that we just created. Alright, so all we did is we are storing the historical klines in this class. Again, we implemented the functionality to store historical klines, And whenever a new socket.io connection is received, we are sending a snapshot of the historical bars on K-line topic. Alright, let's save it. Now let's work on the client-side code. On the client side, we're going to create index.html file where we're just going to have a div element that holds the chart, and we're going to import 4 scripts. First is the socket.io module to establish socket.io connection to the server, and then we're going to import a custom version of the Tradingview lightweight charting library that allows you to create panes, and we're going to have K-line and index.js files. So K-line.js is where we're going to create a class and handle all the rendering logic. Alright, and then index.js is the entry level file where we will abstract away all the code and have a simple main function. And again, I'm running through these steps really quickly because I've already talked about this repeatedly in my older videos, so I don't want to drag this video and make it longer than it needed. Inside the Kline.js file, we're going to create a class called Kline chart, and this is where we'll handle all the rendering logic. And inside the constructor, we're just going to initialize the chart properties, get the DOM element, and then create a chart by using lightweight chart.createChart. And then we're going to create a candlestick series by using the add candlestick series method. Alright, and then we're going to have another method called load historical data, where we'll pass the historical K-line data and set the candlestick chart. Alright, again, we did this repeatedly in my older videos, so I'm just going through these steps really quickly. And in the main index.js file, we're going to have a function called main, and inside that function we're going to instantiate the K-line chart class that we just created, and we'll pass the ID of the div element that hosts the chart. Alright, and then we're going to establish a socket.io connection to the server, and whenever we receive the data, the historical data on K-line topic, I want to get the data by calling the method load historical data. Alright, and I also want to console log the data to show you how it looks, and we're also going to add the other event listeners on connect and on disconnect. That's it. When you hit save and go to index.html file and open a live server. As you can see, the chart looks good, and it is a static chart for now. We are just dealing with historical data. We did not add any real-time aspect to it yet. If you go to developer tools and open the array, you will see how the data is structured. So you have time, which has the timestamp in seconds, and open, high, low, close, and volume. So it looks good. Now let's make this chart real time. To make the chart real time, go to the proxy server and inside the klines.js file, where we have a class that hosts the historical data, we're going to import the WebSocket module, and we're going to use this module to establish a socket connection to the Binance server and then retrieve real-time candlestick data. So inside the initialize method, after we retrieve all the historical candlestick data, we're going to call this.connect, a new method that we're going to create. And inside this method, we're going to handle the WebSocket connection. So inside this connect method, like I said, we're going to establish a new WebSocket connection to this symbol and this interval because we are dealing with that data. Alright. And once we establish the WebSocket connection, we're going to add on open, on error, and on close event listeners. And then we're going to create an on message event listener. Inside this on message event listener, we're going to first check whether we are receiving candlestick data, and when we are receiving candlestick data, we're going to format it in the required format, and then we're going to set the value using the set method. Again, because timestamp, right, the candle open timestamp is going to be the same as long as the candle is open. It's going to override the exact timestamp, and we don't have to use, if we were using an array to store K-lines, we would have to filter and then map, which would again be very inefficient way to handle things. But because we're using map, you can just set the value using timestamp as the key. Finally, whenever we receive any real-time data, we need to emit it to the browser. So we'll add on K-line method, and we'll also implement a dummy on K-line method outside this class. So whenever this on K-line method is triggered, we're going to emit the last received formatted real-time candlestick. Let's save this. Go back to proxy.js file, and here just add this extra event listener. So whenever on K-line method is called on the Binance WebSocket, we're going to emit the real-time candlestick to the browser. Save, go back to the client, and here let's remove the console log data. And by default, the historical data is going to be in the form of an array, right? But the real-time K-line is going to be an object. So let's differentiate that. And whenever is an array, we just call the load historical data method. And whenever it's just an object, it means it's real-time candle, and we'll use update kline method, which will create shortly to handle that. Let's save, go to kline.js, and here let's just create a method called update kline. And inside the kline, we can just call the update method to update that particular candle. And again, we don't need to format the data because it's already formatted on the server. Let's hit save. And now if you go back to the browser, you should see the real-time candlesticks. So if I hit refresh and let's wait for a second, you will see the value getting updated. It's 15, 15, 16, 68,515.16, 25. You can see that the values are 89, values are being updated. So now we have real-time candlestick data. Let's add our first indicator, that is a simple moving average. In order to add indicators, we're going to use this library called WJS indicators. In my previous video, I used tooling indicators, but tooling indicators is only designed to work with historical data. But in this case, we need to deal with real-time data. And the way this library handles real-time data is by offering us two methods. So if you are dealing with historical candles, we can use the next value. But if you are dealing with a candle that's already open, then we use moment value. So let me explain in detail. So let's take this chart, right? So you have 1 hour candlesticks. So the current bar will remain open for 1 hour, right? But all the historical bars are already closed. So whenever you're calculating for the historical bars, you would use the next value method. And whenever you're dealing with current bars, the bar that is still open, we use moment value so that it just updates the last value in the series. And even if you look at benchmarks, right, this library seems to perform much better than all the other libraries out there. So do give it a try. The only downside I noticed is it doesn't support a lot of indicators. So as of now, from what I've seen, it only supports around 24 indicators. Toolend supports over 100 indicators. So I wish, the developers would support more indicators in the future. But I really like how this is structured, and this is ideal for dealing with real-time data. Alright, to implement simple moving average, go to the klines.js file in the proxy server and first import the simple moving average indicator from WJS. Then let's initialize this indicator. We're going to calculate simple moving average 100 for a length of 200. So we'll initialize this inside the constructor, and then when we are calculating the historical bars, we'll add a new key called SMA. And whenever we are dealing with the last candle, because the last candle is still open, we calculate using a moment value, and for all the other bars, we calculate using the next value. Alright, but let's hit save. And then we need to do the same thing on message event listener when we're dealing with the real-time data. First, we'll check if the candle is closed or not, and if the candle is closed, we will call next value, otherwise we will call moment value. Save. Then go back to kline.js file on the client side and create a new series called SMA series with line color to orange and line width of 5. And then we're going to create a method called extract data. So the candlestick data on the server, right? We need to retrieve a particular key. And the reason we're creating a separate method is because let's say for SMA, it's going to be a static value, but if you're using MACD or Bollinger Bands, you will have multiple values within a particular key. So we're going to create a new method called extract data, and we will extract a particular key from the historical data. And we'll use that method in the load historical data function to set the value of the series, and that takes care of the historical data. Now for the real-time data, we can just call the update method. So again, whenever we have kline.sma, we just call the update method inside the SMA series and set the value. If you hit save and back to the home page, you will see an orange color SMA line on the chart, and it is real time. So if I leave it for a few seconds, you can see that the values are changing. So it is a real time visualization. So that's it. So whenever you want to add a new indicator, go to the proxy server kline.js file and then implement that indicator. And you need to do the same on kline chart class on the client side. Alright, now let's do the same for exponential moving average. Alright, so as always, just import the exponential moving average from the library and let's initialize this in the constructor. We're going to calculate EMA 21, a length of 21. So initialize that in the constructor, and in the historical data, we'll have something similar to SMA. We'll have EMA and EMA.next value and EMA.moment value. Alright, let's hit save. And similarly, for the real-time data, we will have a similar key to SMA, which is EMA, and whenever the bar is closed, we call next value, otherwise we just call moment value. Alright, let's hit save. That's it. So we implemented EMA on the server side. Now let's do the same thing on the client side. So if we go to K-line chart on the client side, let's create a new series called EMA series. Then in the historical data method, we're going to set the data for that EMA series. And for the real-time data, we just need to use the update K-line method. And whenever we have kline.ema, just pass the EMA value, EMA series value. That's it. It's safe. And if you go to the chart, there seems to be an error. If you go to klines.js, you can see that I set it to SMA instead of EMA, so let's change this to EMA. And if you go back to the page, hit refresh, you should see blue color EMA line. I'll increase the width so that it's visible. I'll increase the width to 5, it's safe, and you should see the EMA line as well. And always, I'll just leave it for a few seconds and you will see that it is a real-time value. That's it. Now let's implement RSI, which is slightly tricky because it needs to be plotted on its own separate pane. Because again, RSI shares the same x-axis with the chart but doesn't share the same y-axis, right? RSI value is between 0 and 100, so it needs to be plotted on its own pane. As always, to implement RSI on the server side, let's import RSI indicator from the library and initialize it in the constructor. I'm going to calculate RSI 14, which is a default value, and in the historical data, we will do the same. We'll create a new key called RSI, and for the last bar, we calculate moment value, and for all the other bars, we're going to calculate using next value. And then for the real-time data, we're going to do the same. When the candle is closed, we set using the next value, otherwise we just use moment value. Let's hit save. Now we have RSI values on the server. Now to implement this on the client side, we need to plot it on a separate pane, right? So all the visualizations we have right now, the chart and the two line series, these are going to be part of pane 0, which is a default pane, and RSI is going to be part of pane 1. So the way this works is panes are plotted in from top to bottom. So pane 0 is going to be on the top, pane 1 right below that, and that's how we get the chart on the top and RSI right below that. So first in the K-line chart class, I'm going to set all the existing series with pane 0. Then I'm going to create a new series called RSI series with pane 1. And again, we did the same steps for the other indicators. I'm going to set the historical values in the load historical data method for the RSI series, and same thing with the real-time values. Whenever we have the RSI value, just update the value in the update K-line method for the real-time data. That's it. Let's save. If you go to the browser, you should see RSI right below that, and you can adjust the height of the pane and it just works. So isn't that beautiful? Again, needless to say, but this chart is real time. As the last bar keeps getting updated, the indicators are also updated accordingly. Now finally, let's add MACD indicator. MACD indicator is slightly more complicated than RSI because RSI indicator only returns a single value, which is the RSI value, whereas MACD returns 3 values, right? MACD returns MACD signal and MACD histogram. So we need to plot 3 series inside a single pane right below RSI to properly visualize MACD. So let's look at that. As always, let's import MACD from the library. I'm first calculating MACD on the server, then I'm going to initialize MACD in the constructor and calculating for the default values, which is 12, 26 and 9. Then for the historical values, whenever we are dealing with the last bar, we update using moment value, and for all the other bars, we use next value, and we do the same for the real-time data. Just temporarily, I want to console log the K-line data to show you how the MACD values are captured. As you can see, RSI, EMA, all the other values are set as a number, whereas MACD is set as an object with multiple values. So we have MACD, EMA fast, EMA slow, signal and histogram. To properly plot MACD, we need MACD key, signal and histogram, and these are nested values, right? So we are going 2 levels deep. So first level we have MACD, and we are going another level deep to get the values. So which is slightly different to all the other indicators that we just plotted. Alright, I'm going to remove the console log function and let's implement MACD on the client side. And to implement MACD, like I said, we need to plot 3 series, 2 line series and 1 histogram series right below the RSI plot. Alright, so first I'm going to create fast series, which is a line series, and I'm using paint 2 because it needs to be below the RSI series. And then I'm going to create a slow series, which is going to be in color red, and again the pane is going to be 2. And then we'll add a histogram series on the same pane. Let's hit save. Now, just like extract data method, we'll have extract nested data method because we need to go 2 levels deep to retrieve the MACD values. Alright, and then we'll use this method to populate the values in the load historical data method. So in the load historical data method, we are first going to set the fast series, and instead of using extract data, we'll use extract nested data method. And then we're going to set the slow series and then the histogram series. Alright, let's hit save. And we need to do the same in the update kline method for the real-time data. That's it. Whenever we have MACD, we just destructure MACD, signal and histogram, these 3 values from the MACD object, and then we'll update the values to the series accordingly. Let's hit save. And if we go back to the page, we should see MACD series right below the RSI series. This looks good, but there is a catch. The histogram value needs to be red if it's below 0 and green when it's above 0. So to implement that, the historical data, after we retrieve the histogram values using the extract nested data method, this value is going to be an array of objects with timestamp and value. So what we need to do is whenever the value is above 0, we set the color to green. If not, we set the color to red. Okay? So we do a map, and then whenever the value is greater than 0, I'm using aquamarine, which is a better version of green, and Indian red for the values less than 0. Let's hit save, and we need to do the same thing for the real-time data. That's it. Let's save it. You can see that the MACD values, the plot looks much better. Alright, that's it for this video. I just wanted to show you how to plot real-time indicators using the lightweight charting library, and this is how you can achieve it. Before I wrap up the video, I just wanted to mention a few things. I've used ChatGPT to write the code for this project, and more than 90% of the code is written by ChatGPT. So sometimes I wonder if there is any merit to making these videos, because anybody can do the same by making a few prompts to ChatGPT. So I'm not really sure if there is any value in making these tutorials. What do you think about this? Do you really find these tutorials useful, or is it just repetitive and boring because you could already do the same using ChatGPT or Sonnet or Cursor or any AI coding tools? Let me know in the comment section, and I'll talk to you in the next one. Bye.